What is the use of cement in life? Raw material used for producing cement. Process of cement making and chemical reaction. Final composition of cement. What is mortar and concrete? Why calcium sulfate is added to the cement? Why are cement and concrete used for construction? How cement sets, or how cement becomes hard after it is mixed with water. Cement. Uses of cement. The cities of today have tall buildings, long bridges, tough roads. All of these are made up of cement. In our daily life, cement is widely used in construction, making pipes, bonding the surfaces of various materials, or for coating surfaces to protect them from chemical attack. Raw material used for producing cement. Cement consists of particles containing compounds of calcium, iron, aluminium, silicon, and oxygen in varying proportion. The typical constituents of Portland cement are calcium oxide, approximately 61 to 67% of the mass, silicon dioxide, about 19 to 23%, aluminium oxide, 2.5 to 6%, ferric oxide, 0 to 6% of the mass, and sulfur oxide, 1.5 to 4.5%. Cement is made by roasting a powdered mixture of calcium carbonate, that is limestone or chalk, silica, which is sand, aluminosilicate mineral, which is kaolin, clay or shale, and iron oxide at temperature of 870 degrees to 1500 degrees Celsius in a rotating kiln. The kilns of modern cement plants run at 4 to 5 rpm. During the operation of the rotary kiln, flames can reach temperatures as high as 1900 degrees Celsius or 3452 degrees Fahrenheit. Hence, the four main raw materials for cement are limestone, CaO, silica, SiO2, aluminium oxide, Al2O3, and ferric oxide, Fe2O3. Process and chemical reaction of cement making. Initially in the process, limestone and the other ores are powdered by a crusher and then uniformly mixed in a blender. The mixture is then passed over rotating kiln where it is roasted at temperature of 870 degrees to 1900 degrees Celsius. Initially, in kiln, the CaCO3 decomposes into carbon dioxide and calcium oxide. CaCO3 changes to CO2 plus CaO. Then, at 1350 degrees Celsius to 1500 degrees Celsius, CaO combines with SiO2, Al2O3 and Fe2O3. The equation goes like 12 CaO plus 2 SiO2 plus 2 Al2O3 plus Fe2O3 changes into 2 CaO SiO2 plus 3 CaO SiO plus 3 CaO Al2O3 plus 4 CaO Al2O3 Fe2O3. As the mixture passes through kiln, it loses water and carbon dioxide and ultimately forms a clinker containing partially fused material. Again, it is powdered in a grinder, calcium sulfate is added to the mixture, and then it is packed in bags. Why calcium sulfate is added to the cement? When water is added to cement, hydrolysis of calcium silicate takes place, which actually is the setting process of cement, that is, the hardening process. The above reaction happens very fast, not giving enough time to keep the cement workable after mixing water. To slow down this process, a small amount of calcium sulfate or gypsum is added to the cement. Gypsum also allows tricalcium silicate to set first, retarding the flash setting of tricalcium aluminate. Otherwise, the strength of the cement paste is adversely affected. Hence, the final composition of cement is 54% of tricalcium silicate, 16% of dicalcium silicate, 11% of tricalcium aluminate, tetracalcium aluminoferrite 9% of the total. Small amounts of magnesium oxide, magnesium sulfate, sodium and potassium oxides are added. What is mortar and concrete? Cement is usually mixed with other substances. Mortar is a mixture of cement, sand, water and limestone. Uses of mortar. Mortar binds together the bricks or stones in brick or stone masonry. Mortar fills cracks and spaces in wall and floor. Mortar is also used in plastering works to hide the joints and to improve the appearance. Mortar also provides water tightness against the weather. What is concrete? Concrete is a mixture of cement, water, sand, and crushed stones. It does not contain limestone. Composition of concrete. Concrete is made up of cement plus fine aggregate sand plus coarse aggregate consisting of stone and brick chips plus water. Why are cement and concrete used for construction? In engineering and building construction, Cement, that is the paste with water, is used as material that adheres to or glued with any other material such as stones, bricks, and becomes hard after drying. How cement sets or how cement becomes hard after it is mixed with water. Composition of cement is tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. When cement reacts with water, hydrolysis of calcium silicate takes place. C2S plus C3S plus C3A plus C4A plus water results in the hydration of cement. When water is added to cement, the cement particles get suspended under water. Reactions with water start taking place in a few hours' time. The hydration reaction itself consumes a specific amount of water. This is how the fully hydrated cement looks like. The equation of the hydrolysis of calcium silicate is as follows. 2C3S plus 6H changes to C3S2H3 plus 3CaOH2. 2C2S plus 4H changes to C3S2H3 plus CaOH2. C3A plus 6H changes to 6,3AH6. This forms a wet sticky gel that adheres strongly to other particles like sand and crushed stones. The gel spreads on a large surface area and is ultimately responsible for the great strength of concrete. The setting process also involves the formation of small densely interlocked crystals after the initial solidification of the wet mass. The minimum setting time is 30 minutes and the maximum setting time is 10 hours. The interlocking crystal formation continues for a long time after the initial setting and it increases the strength of the cement. Water is required for the setting process because the reaction involves hydration.